Uh, okay, guys. Today we are going to discuss about binary tree and binary search tree. So before getting into that, so basically we need to just know what is meant by binary tree. Basic definition. So binary tree is a non-linear data structure with a maximum of two children for each parent. Every node in a binary tree has a left and right reference along with the data element. The node at the top of hierarchy of a tree is called as a root. The nodes that hold other subnodes are parent nodes. So basically this is a binary tree. So let's just get to it. So okay. Let me just download one of this okay, let me just create one binary tree for now. So okay, basically this is the root. So this is known as root. So I am now taking the root value as 5. So let me just declare this. So this is root. So basically the topmost element of the tree is known as root in a binary tree. And now we will just divide them into branches. But one of the most common rule is in a binary tree, every root should consist of only two children. So this is a very basic common rule. So we need to just remember that binary tree itself in the name it consists of two. So only two children must be present for a binary tree for each node. So basically, the left side will be the smallest one, and the right side will be the greatest one. So the left is small, and the right is big. So what is small? What is big? So let us just see. So small is nothing but the number which is smaller than the root will be to the left side of the root. So let us not just confuse. So the values which were less than 5 are 4, 3, 2, 1, 0. So let me just place a value to here, and greater than 5 is 7. So basically the values which are less than root will be located at the left side of the root in a binary tree, and the values which are greater than root will be located at the right side of the root. So this is a very basic binary tree. So let's just see some of the binary trees. So let me just open this Java T point. So let me just insert this numbers as a binary tree. So let me just do that. So okay. So my root value is 43. Let me just place that. 43. So 43 is my root value. And then the next one is, so the 43 is completed. And the second one is 10. As 10 is less than 43, so it will be at the left side of the 43. So now I'm writing 10 here. So 10 stays at the left side of 43. And then comes 79, which is greater than 43. So it will just stay in this right side. So 79. 79 stays at right. And then comes 90, which is greater than 43 and also greater than 79. So it stays at the right side of 79. So let me just give the value here. So then next is 12. So 12 is less than 43 and greater than 10. So it will just stay the right side of 10. So here we are going to write the 12. And then next is 54. 54 is greater than 43 and less than 79. So it stays at the left side of 79. Let me just move this a bit. So okay, it's left side of 79. That's 54. And then 11. 11 is less than 43, greater than 10, but less than 12. So it will just stay here. I think this is fine till here. So let me just draw the notes. 43, 10, and 17, 79 for 54 and 90. So 10 for 12 and 12 for 11. So this is a very basic binary tree with this elements. I think this is fine with binary tree. And then if you just go down, we will have searching in binary tree and insertion in binary tree, deletion in binary tree. But the only difference is we call it as a binary search tree. It is also more similar to this binary tree. So in this way, we will just use this binary tree. So there are some types of binary trees. There are full binary tree, complete binary tree, perfect binary tree, degenerate binary tree, balanced binary tree. So full binary tree is nothing but defined as a tree in which each node must contain two children except the leaf node. So basically each root node should contain at least two children. So that is known as a full binary tree. So this is the condition for checking that. And complete binary tree is in which are completely filled except the last level. So all the nodes must be as left as possible. So if it is containing more nodes at left, then it is known as a complete binary tree. And the perfect binary tree is the internal nodes must have two children and the leaf nodes are at the same level. So this is known as a perfect binary tree. Here we can just see all the elements are at a base level. And then last degenerate binary tree. This is also known as a skewed tree. So skewed right tree and skewed left tree, in which the searching will take a very worst case, because we can't just find the element by checking one after another. So skewed tree is one of the binary tree in which the searching shows a very worst case. And then it comes for the implementation. So we just implement the data in it. So in order traversal, pre-order traversal, post order traversal. So okay, now we need to just discuss about pre-traversals. So in this we will have three parts: in order, pre-order, and post order. So in this way we can just arrange the elements in a proper order, so that we can just find those elements very clearly. So in order condition is left root right, and pre-order condition is root left right, and post order condition is left right root. So let me just copy this image and paste it in Paint so that I can just explain it somewhat here. So yeah, now the first condition is left root right. So this is in order. So in order condition is left root right. So yeah, now we need to just consider the value of left first. So before considering the value of left, we need to just check the root. So the root has a left, and the left root and the left child is also a root. So it is also having a left, that is 4. So we need to just write the element first as 4, and then it comes to root. So then the root value is 2, and then write 5. So it just traverses back to its root again, that is 1, and then write 3. So this is the in order condition for this binary tree. And then the next one is pre-order, that is root left right. So let me just also write for that. So now we are discussing about pre-order. So the root is 1, and then the left is also a root. So we need to just write it, and then we need to just write the left one that is 4, and then right that is 5. And if we just come back again, it's 3. So this is the pre-order condition, and then post-order that is left root right. Left root right. So this is the post order condition. Now we need to just check the leftmost value, and then while coming to this 1 2 4, 4 is the leftmost, and then right is 5, and then root is 2, and then left has been completed, then 3, then 1. So this is the pre-order, in order, post order conditions for the traversal. So with this we can just find the elements very easily without any confusion. So for this reason, tree traversals are used. uh, so okay guys, then last one is this is one of the important deletion of uh, deletion of elements in this. So before just checking into the deletion, we need to just know how to insert. As we said before, we will just insert the elements like this. So now we will just discuss about the deletion of elements. So deletion of an element is nothing but, so if we just see, so we can just delete in 3 types, that is deletion of a leaf. So leaf is nothing but which is having no child, and deletion of root which is having a one child, and the deletion of root which is having two children. So these are the 2 types. So now we need to just discuss about the first thing, that is deletion of leaf. So if we just delete the leaf like this which is having a null value, nothing will happen, because this will stay the same. We need to just break the relationship between this leaf and the before one. And if we just try to remove this node which is having one child, so it is a little bit complex thing. So if we just delete this element, then we need to just put this into the appropriate position. As 11 is just greater than 10, we need to just place it to the right side of thing. So we need to just do like that. And then while coming to the deletion of a node having a two children, so this is one of the complex tasks. So we need to just check a condition like, so the minimum value of left should be taken, sorry, not the minimum one, I'm sorry. So the maximum value of left should be taken, or the minimum value of right should be taken. This is because if we can just see like the maximum value of left is 54. So 54 is less than 90. So it will just satisfy the binary condition. So the binary search condition is the root node left should be less than the root node, and the right should be greater than the root node. So this should not be violated. So that for satisfying this, this is one of the most important condition which we need to follow while deleting the two nodes. So I think this is clear. So if we need to just delete this node, we need to just take the maximum of the left. That is, we need to just make this 54 as the root, and we need to just place it at the right side as similar. And the minimum of the right, so that is 90, and we can just place it as 54 here. So I think the deletion techniques are also very similar. And the upcoming topics we will just learn about AVL trees, in which the elements, insertion of elements will be in a different way, which depends upon the balancing factor. So that will come in the next topics. So this is about binary tree. Thank you guys.